Okay, one final note on the chi-squared statistic. I often get asked by students here, well, if my data doesn't fit this rule, let's say I do need to look at a numeric feature because it's too highly skewed, or for whatever reason it doesn't fit the normal distribution, or my label's categorical, so I want to treat my feature as categorical as well, even though it's numeric. Basically, they want to run a chi-squared test, and their data doesn't meet this rule that you need at least 5 observations in each cell. So what do? Well, the solution there is to bin your numeric features so that we have at least a certain number of observations in each cell. So let me show you what I mean here. Let's go back to Tableau. There we go. And recall back when we made our histograms, like the charges histograms. So what this represents then is that there are 68 people that cost between 0 and whatever the ending point of this bar is right here. It looks like it's about 1,667 or something like that. Well, when we made the histogram, you might have remembered or noticed that it actually created 4 new dimensions up here. Excuse me, when we created all 4 of the histograms for the 4 numeric features, it created these binned versions. Now let me show you exactly what that is. Come back here to the data source, and here's our original feature of charges, or our label. And when we made the histogram, it also added, let's see if I can find where I put that now. That ended up the binned version. There we go, at the end. A charges bin. Now, what exactly does that mean? Can I move that over? No, I guess I can't. So what it's got here is this value is now 0. This one's 15,903. Let me scroll over. Look, these two values are now the same, and these values are the same. Let me scroll over to the original charges. Notice here's a charges that was really small, and then here's some that were similar. Basically what it did was, it, as you might realize, it relabeled every case with the edge of the bin. So, and in particular, the left edge of the bin, the minimum. So anything that was under this width right here, which must have been between 0 and maybe 1800 or something, it relabeled it to 0. So now every one of these 68 cases in this bin all have the same value of 0, which means in a chi-squared crosstab or a contingency table, I now have 68 features with the same value. Right here now I have these 164 features have the same value. In other words, even though there is an order to these, higher ones are lower than, or higher than lower, the lower ones, we can now use this histogram charges bin as a substitute for charges, and then run a chi-squared score to predict whatever categorical feature it is that we want. So let me give you an example of this from scratch. Let's say we hadn't made this histogram of charges. Let's go here to a new sheet. And what I want to do is, let's see if we can predict, let's predict smoker by BMI. Let's see if smoking makes you lighter or heavier, or what it's related to. Or if being heavier, maybe being heavier causes people to smoke, or lighter causes people to smoke. So I'm going to pull smoker in here to either columns or rows, and I need to create a new binned version of BMI. I don't want to use that version. I'm going to just show you how to do it from scratch here. So I go to BMI, create bins, and sure, we'll let it be called bin 2, and it's going to suggest a particular bin size. How does it come up with that? Well, Tableau does have a formula. Let's see if I can pull it up here and show it to you. The formula they use for bin size, right here, number of bins equals 3 times the log base 2 times log of the count. What is the right number of bins? Well, there's a million answers to that. And actually, if you take a look at the histogram page on Wikipedia, they give a nice overview of the many different, this is Wikipedia, let me show you the URL, /histogram. And they give a nice overview of a million different measures to come up with the size, the number of bins, or the width of the bin, based on the number of samples and the min and the max and the interquartile range and all these things. Basically, you can pick any formula you want to come up with size of bins, or you can just let Tableau stick with Tableau's suggestion if you want to. Here what it does is it tells you the size of the bins. It doesn't let you choose the number of bins. So let me just show you. I can go in and I can change it, or I can come up with my own. Here's where I can come up with a new parameter. I can click that or go over here. And I can basically right-click and create a new parameter over there to implement one of those metrics I showed you on Wikipedia to determine bin size. Let me just hit OK, and here's what it creates. Notice this version is green. It's treated as a continuous measure, whereas this version is discrete. So I'm going to pull this version in that I just created from scratch. And here's what I get. I think I like the other format better. Well, maybe not in this case. We'll leave it like that. So once again, it doesn't know what to put in here. It's not sure what I'm looking for, but look what it puts over here on the left. So bin, this is the edge of those bins that I created. Now notice it's different. My lowest value here is 15.96. So this is based on that formula that I showed you a moment ago. 3 times the log base 2 times log base n, or 3 plus log base 2 plus times log base n of the count. So don't worry about interpreting this number over here. It really just represents a unique value. And there's a certain number of cases now that all have this value. So if I go to data source and scroll over, you should be able to see now. Here, the value it puts in here is the bin number. So this tells me, it looks like I've got, give me a max value here. There we go. Oh no, it's just, I think maybe all it's done here is rounded this number. So it's given me 27 unique bins. So it's not the bin number, excuse me, it's just a rounded value of that formula over here. So I'm going to close on that, and let's go back to here. Now what we need is to put a count of the number of values that are in this bin that are non-smokers and smokers. So to do that, pick any cell or any measure or any dimension, doesn't matter what it is, that has no nulls that we can count. I'm just going to use charges. I'm going to drop it on label. Okay, and I'm going to change sum to count. And we got to get rid of these little blue marks. So let's go to show me. Now that we have this, I think we can use, there we go, we can use this guy right here, the highlight table. All right, so I'm going to switch back to this view again so you can more easily see what this has done. And you can tell by the formula they tried to use, they're trying to make a more normal distribution here of the number in each bin. So just, you can see the numbers get higher. I get a lot more here as I get towards the middle. Then they get lower and lower and lower down here. Anyway, I'll stop here, but the idea is you could continue with the previous video and recreate all those metrics needed to create a chi-square statistic here, now based on these categorical values and these categorical values. But I won't go through with that here since you can watch that in the prior video.